All right, welcome back to another lesson. Today we're going to take a look at radicals. And radicals are related to what we learned about in our past lesson about powers. They're actually the inverse of powers. So in the previous lesson, we took a look at things like this example, 2 to the third equals 8. And a radical is kind of the opposite of that. So if we take a look here, we have the cube root of 8 is 2. So basically what this is saying is what number can I multiply itself by 3 times to get the number 8? And that number is 2. Or like here, for example, 3 to the 4th power is 81. So if we were to do the radical of that, we would find the 4th root of 81 would be 3. Or in other words, it's saying, what number did you multiply by itself 4 times to get 81? Well, that number was 3. And there's some rules for working with radicals. And these are going to be sort of confusing, but that is, we take a look at the different examples. I think you'll see what they mean. You don't necessarily have to memorize this wording or anything, but it's important that you kind of understand the concept of it. So we're going to use this little example here that they gave us, the nth root of a. So when they talk about n and a, you can refer to that to see what it's actually talking about. So the first rule is, if you have an odd root, there's only going to be one real root. Or rather, if n is odd, you're only going to get one root. So, for example, here it says the third root of negative 27 is what? So, with this, we can go into our calculator. And all of these, you can use your calculator. So, we want to do the third root of negative 27, and that is negative 3. And so, the reason why we say there's only one root is because there's only one way I can multiply a number by itself 3 times and get negative 27. There's only one way to do it, and that's negative 3 times negative 3 times negative 3. But if I have an n that is even, you can actually have 2 different roots. So let's talk about why that is. So they give us the example of the 4th root of 81. So if we go in here and we want to do our 4th root of 81, we get 3. But we need to think more about what that means. So if I have were to write that out, I would have 3 times 3 times 3 times 3. But we know that with multiplying negative numbers, if you have 2 numbers that are negative and they're multiplied together, they become positive. So it is possible that I have another root, which is negative 3. So if I do that same thing, negative 3 times negative 3 times negative 3 times negative 3, well, I know these 2 negatives are going to become positive, and these 2 will become positive. And when you multiply 2 positive numbers together, you get a positive answer. So negative 3 times negative 3 times negative 3 times negative 3 also gives you 81. So you just need to pay attention to those even ends. And there is a way we'll look at in the next problem that shows you when to give the positive version and when to give the negative version. Okay. And then if we have n and a is 0, it's only going to have one root, and that is 0. So again, if we take the square root of 0, 0 times 0 is 0. If we take the cube root of 0, 0 times 0 times 0 is still 0. You could do the 100th root. It's still going to be 0. And then last but not least, if we have an n that is even, but the number inside is negative, there's going to be no solutions. So again, let's think about why that is. So let's say that I've got the 4th root of negative 81. So right away, I'm noticing that even number. So that basically means I have 4 numbers that I'm multiplying together that's going to somehow need to give me a negative 81. Well, we know if these are all 4 numbers, even if they're all negative, well, we know this negative times this negative becomes positive. This negative and this negative becomes positive. And a positive times a positive is always going to stay positive. So there's no possible way that I can have an even n value and somehow end up with a negative value for a. It's just not positive. Or it's just not possible because those pairs of numbers are positive. So if we take a look at some examples here, this one says they want us to find the 3rd root of negative 64. So just kind of thinking through this one, I already know that this could be possible because I do have that odd n. So it is possible to have a negative root. So let's go in here and plug her in. So we've got the 3rd root of negative 64. That gives us negative 4. And again, because that's odd, I know there's only going to be 1 root. Now for part B, we want the 2nd root or the square root of 81. And again, because this is positive, I know that it's going to either be a positive or a negative 9. Because again, I know that a 9 times 9 is 81, and I know negative 9 times negative 9 is also 81. And they don't tell us which one they want for this one, so we have to put that little plus minus symbol like this. So that's showing it can be plus 9 or negative 9. Now for these examples down here, this is going to show you how to differentiate which root they want. For A and B, we've got the 4th root of 81, but you'll notice that this one is just the 4th root of 81, and this one has a negative on the outside. So that negative on the outside is going to indicate that you need to put the negative root. So if you go into your calculator and you find the 4th root of 81, you'll find that it's 3. And again, in this example, because we don't have anything on the outside here, that's indicating it's the positive root. Whereas with this one, with the negative on the outside, that means they're looking for the negative root. So in this case, it would be negative 3. So as we look at these last 2 examples, both of them are odd n values. So I know they're only going to have 1 root. So I don't have to worry about putting the plus minus or looking out for anything like that. So when you plug these into your calculator, that's the nice thing is you can always use your calculator on these. The 3rd root of negative 8 is negative 2. And the 5th root of 32 is positive 2. And again, I just got all of those straight from the calculator. All right, so the important things to remember are kind of those ones up here. Just reminding yourself that if we have an even n value, there could be 2 possible roots. If it's odd, there's just 1.